Hello friends, this video on work, energy and power part 24 is brought to you by examfear.com. No more fear from exams. Please make sure that you have watched all the videos from part 1 to 23 before going ahead with part 24. Cart is moving over a horizontal surface at a velocity of 50 cm per second. It is hit by another cart which is moving in the same direction at a velocity of 150 cm per second. So that means, let us suppose for the cart 1, the velocity is v1, which is 50 cm per second. Now for cart 2, the velocity v2 is equal to 150 cm per second. It says after collision, the carts continue to move in the same direction at the same velocity of 100 cm per second. That means after collision, this is before collision. Let us follow the same convention. This is before, this is after. So after collision, they both move with a velocity v is equal to 100 cm per second. Find the ratio of the masses of the carts. So masses are not given. Let us suppose this first cart has mass m1 and the second cart has mass m2. Applying the conservation of momentum, what do we get? The total initial linear momentum should be equal to the total final linear momentum. So what is the total initial linear momentum? m1 v1 plus m2 v2. What would be the total final linear momentum? Final momentum would be m1 into v plus m2 into v, because both m1 and m2 move with the same velocity. Now let us try to solve this. m1 v1 plus m2 v2 is equal to m1 plus m2 into v. Now if I divide this entire equation by m1, we get v1 plus m2 by m1 into v2 is equal to m1 plus m2 divided by m1 into v. Therefore, we get m2 by m1 into v2. This is equal to 1 plus m2 by m1 into v. v1 plus m2 by m1 v2 is equal to 1 plus m2 by m1 into v. So we have to find the value of m2 by m1, right? So we will do simple mathematics. That is v1 plus m2 by m1 into v2 is equal to v plus m2 by m1 to v. So we can say m2 by m1 into v2 minus v is equal to v minus v1, which implies m2 by m1 is equal to v minus v1 divided by v2 minus v. Now we'll put the values of v, v1 and v2. v1 is 50, v2 is 150 and v is 100. So v is 100, v1 is 50, v2 is 150 and v is again 100. So we get 50 divided by 50. So we get 1. Therefore, we find that the ratio of the masses of the two carts is equal to 1. That is, both the carts are of the same mass. So what we did here is, we just applied the conservation of linear momentum. As I told you before, writing the equation for conservation of momentum, you make this column for before and after. Just write down the masses and velocities of the objects before collision and masses and velocities after collision. Then you write the conservation of momentum, or if required, conservation of energies equation. Now let us look at problem 2. It says a cart is moving over a horizontal surface at a velocity of 50 centimeters per second and collides with a cart of the same mass which is at rest. That means there is one cart, say of mass m1, which is moving with velocity v1 is equal to 50 centimeters per second. It collides with another cart of same mass. That means the mass of the other cart is also m1, and this is at rest. That means the velocity of this cart, which we normally call v2, is equal to 0. Now both of them collide. As a result of the collision, the moving cart comes to halt. So this is the scenario before collision. Now what happens after collision? Let's see. After collision, the mass which was moving before comes to rest. That means m1 comes to rest. So the velocity of m1, that is v1 dash, becomes 0. What is the velocity acquired by the second cart? That means that for second cart, mass is still m1. And what is the velocity acquired? So we need to find the value of v2 dash. So here also we will apply the momentum conservation. So what is momentum conservation? Total linear momentum initially, that is before collision. What will be the total initial momentum? m1 v1 plus m2 v2. Now here m2 is also m1 v2. And the total linear momentum after collision would be m1 v1 dash plus m2, which is again m1 v2 dash. Here we see that v2 is equal to 0. So we can write m1 v1 is equal to, here again v1 dash is equal to 0. So this is equal to m1 v2 dash. That is v2 dash will be equal to m1 v1 divided by m1. So m1 gets cancelled. So we get v2 dash is equal to v1. So what was the value of v1? It was 50 centimeters per second. That means v2 dash, that is the velocity of the second cart, would become equal to the velocity with which the first cart moved before collision. So this would be 50 centimeters per second. So I hope you got it here also. Just try to understand the question and then put the values of m and v before and after collision. So that will make your solving the question very simple. Now let us look at one more problem. The problem here says that two blocks of masses m1 is equal to 2 kg and m2 equal to 5 kg are moving on the same direction along a frictionless surface with speed 10 meter per second and 3 meter per second. So here we have m1 is equal to 2 kgs and velocity of m1 is equal to 10 meter per second. m2 is equal to 5 kgs and velocity of m2 is 3 meter per second. An ideal spring with force constant K is equal to 1120 Newton per meter is attached to the back side of m2. Let us suppose this is m1. This is m2. The question says that there is a spring which is attached to the back side of m2. That means the spring is attached here because it also says that m2 is ahead of m1. So m2 is ahead of m1 and there is a spring at the back side of m2. Now what happens? This mass moves toward this mass and finally it collides with m2. So what will happen when m1 collides with m2? The spring here, which is attached to m2, will get compressed to its max. So what does the question ask? It asks us to find the maximum compression of the spring when the blocks collide. So here also we'll apply the same momentum conservation first. So according to the momentum conservation, total initial linear momentum, that is m1 v1 plus m2 v2, should be equal to the total final linear momentum. So what would be the total final linear momentum? After collision, the mass will be the mass will become m1 plus m2, and they will move with some velocity, say v. So this would be the momentum conservation. Now let us put the values of, now from here we can get the value of v, which will be equal to m1 v1 plus m2 v2 divided by m1 plus m2. Now let us put the values. m1 is 2 into v1, that is 10, plus 5 into 3 divided by m1 plus m2, that is 2 plus 5. So this will be 20 plus 15 divided by 7. So this will be equal to 5 meter per second. So this is the velocity with which this entire system, that is m1 and m2 together, will move after the collision. Now the question asks us to find the maximum compression of the spring. So now let us apply the energy conservation, that is the kinetic energy conservation. So what will happen in that case? The total initial kinetic energy, which is equal to half m1 v1 square plus half m2 v2 square, will be equal to the total final kinetic energy, which is equal to half m1 plus m2 into v square plus the work done in compressing the spring, because after collision some of the energy is spent in kinetic energy of m1 m2 and the remaining energy is spent in compressing the spring. So what will be the energy in compressing the spring? That will be half kx square. Now from this equation we know m1 v1 m2 v2, we have all the values, and v also. K is also given in the question. So we can very easily find out the value of x. So let us try to find it. So this will be equal to half into m1 is 2, v1 square would be 100, plus half into m2 is 5, v2 square is 9. This is equal to half into m1 plus m2, that is 7, into v square, v was 5, so this would be 25, plus half into k is 1120 into x square. Now this 2 and 2 will get cancelled. This 2 will get cancelled with this. So 2 5s are 10, 0. Now solving this equation, we get the value of x as 0.25 meters. That means when the two masses collide, the spring gets compressed maximum to 0.25 meters. So this would be the maximum compression in the spring. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.